Hey, yo. Section 4.4, systems of linear inequalities. Honestly, I think these are easier than systems of in three variables. It's the three variables is coming up with two new equations, solving those, then plugging back in. Systems of linear equations aren't too bad. What we're doing here, you already did. So think back to chapter 3. Think back to chapter 3 when you had to graph inequalities. And you took the line and you graphed it, and then you put in a test point and said, oh, I'll shade this side. That's what you're doing. The difference is you're doing it twice. So what I mean is they give us an introduction and say, hey, look, graph the solution set for both of these. These are both lines. The difference is this is all the points greater than that don't fall on that line. This one, all the points less than that do fall on that line, including that line. So you can think of this as, okay, let me solve both of these. Solve this one, and you have a broken line because it's not equal to x plus y. When you plot your data points, if you make x 0, y is 4, boom, there's my y-intercept. Make y 0, x is 4, boom, x-intercept, connect them, dotted line. Type in your test point, origin 0, 0. 0 plus 0 is 0. 0 less than 4, true. You're shading this side. Then you do that for the other line they give you. Negative x plus y less than equal to 3. So just plug in points. If it's 0, y is 3. So 0, 0, 3, there's y-intercept. If y is 0, x is negative 3. Negative 3, there's the intercept included. So boom, solid line. Put in your test point, 0, 0. 0 is less than 3, true. Shade that. What you want to do now is put the two together. Put both graphs on top of each other and shade the common area. Where they overlap, shade the common. That other one came in through here. It included everything under it. This one includes everything under here. I like to draw arrows. I'll show you how I do that when I do a couple examples or a couple problems. So again, you can pause this if you have to look over it. But what you're doing is just choose some points. You can choose 2 if they're far enough apart. You can choose 3. You can choose 5, 6, 7. Doesn't matter. Choose enough points to get a good solid line drawn. Make sure you follow the rules for how to draw the line. And then go ahead and plug in any point not on the line. Hopefully it's the origin. Hopefully the origin is out there and you can plug it in. If it's true, shade that side. Now, you can pause that and look it over if you need to. What I mean by shade that, I'll try to keep this fairly painless. I'm going to do number 3 first from problem set 4.4. Number 3 says, hey, y is less than 1/3 x plus 4, and y is greater than equal to 1/3 x minus 3. Now, for plugging in points, you do not have to multiply through by LCD. You don't have to get rid of a fraction. You don't have to do anything. You can just try some points. What I'm going to do is say, I'm going to start with 0. What if x is 0? Well, then y is 4. All right. Well, I have a 3. What happens if x is negative 3? Goes negative 1 times 1 is negative 1 plus 4 is positive 3. If I decide to try 3, since it'll still make it go away, 3 divided by 3 is 1. 1 times 1 is 1, plus 4 is 5. There's plenty of points to graph that one. And I'll graph it and then I'll come back. So we can forget that. I'm going to do it over here. So we have a 0, 4, right there. We have a negative 3 and 3. And of course I have little graph paper, negative 3, 3. And then I have 3 and 5. I have less than, not equal to. I know that means a broken, sorry, the book says broken, a broken line. Just make sure you show that it's broken. If you're using pencil on the test, if you're using pencil and you draw it straight, you can just erase. If you're using pen and you draw it straight, just scribble a couple places to show, oops, I meant broken. You can always fix it. So the next line, I'm going to do the same thing because it's the same fraction. I'm going to do the same exact point. If x is 0 and I zero that out, my y is -3. I'm going to choose -3 again and see what happens. -3 is -1. That means -4. If I make it +3, so it goes away, +3 is +1, -3 is -2. So now I'm going to plot this one. I have a 0, -3. I have a -3, boy, that's small, -4. And I have a 3 and a -2. And equal to, I mean, greater than or equal to. So I know that is a line like that. And you can do all at once, or you can do them. I like to graph the line and go back and check. Now, my origin's open for both of them. My origin is my test point. When I test the origin, that means I have y is 0 and x is 0 plus 4. 0 is less than 4. True. So for this one, I know I'm shading this way. I draw arrows and so I don't get ahead of myself. Then same thing down here. My origin is still open and it's basically the same equation, just one's up 4, one's down 3. 1/3 x is my line. I shifted it up 4 here, down 3 here. But anyway, I'll type in my origin, 0. If x is 0, then 1/3 times 0 is 0. 0 is greater than or equal to -3. That's true. I should have circled because the underline looks goofy. 0 is bigger than a negative. So I know I'm going this way. So I match everything up and I see, oh, I see. It's everything inside there. Done. Graphed it. Let's do another one. We'll do number 11. Then I'll take a breather. 11, we have 3. No big deal. We just have to do it 3 times is all that means. So x plus y less than or equal to 3. X minus 3y less than or equal to 3. X greater than or equal to -2. Okay, same thing. Please, please, please understand there's freedom when it's graphing. Just choose points. You don't have to move anything around. You don't have to worry about what's greater than or less than. You use a test point for that. For getting the line, it's a matter of, let me try some stuff. Well, I'm going to make x 0. If I make x 0, y is 3. All right, well, sweet. What if I make, in this case, what if I make y 0? Oh, x is 3. Okay, cool, gotcha. I can go negative. Doesn't matter, I can check. What happens if I make x -2? I'm going to add it over here. Y is going to be 5. What happens if I try making x 2? Well, I'm going to subtract it. Y is 1. 3 minus 2 is 1. So I found 4 points real quick. You just keep plugging them in. Put any points in that you want to. Now 3 is a little bit bigger number, so I'm not going to go so crazy, but I'm going to plug 0 in for x and have -3y and 3. So I divide by a -3. Now I have a -1. Then, yeah, I'm still going to zero it out. Easiest route. Take the easy route. I zero y out. What happens if y is 0? Well, x is 3. I see the same point here, so I know they're crossing. They're gonna do some sort of cross somewhere. I can choose another one just to stay all crazy like. I am going to do 6. I'm going to say what happens if x is 6, because my graph goes pretty big, just to show you. If x is 6, then I'm going to subtract 6. I'm going to get a negative 3. Negative 3 divided by negative 3 is 1. You can do this stuff in your head. What I'm doing is saying, well, what happens if x is 6? Then I'd have to subtract it over here. 3 minus 6 is negative 3. Negative 3 divided by negative 3 is 1. So 6 and 1 is another point. I could keep going, but I have enough. Now this one, there's nothing to do. X, negative 2. I know that my x is negative 2. That's all that matters. So when I come over to graph this one, let me fold it over. When I come over to graph this one, I'll graph this line first, and this one I'll do a little differently. Since there's 3, I can do my test point. So I can say 0. My first point is 0, 3. I got to snug up here to it to see my stinking small numbers. My next point, I could go 3, 0. Then I can go negative 2, and I found out that was 5. And then I went 2, which I didn't have to, and found out that was 1. Now this one is equal to, so it's a solid line. And if you want to, you can test right away. The origin is open. I'm going to go ahead and throw the origin in. Origin is 0, 0. If I make x and y 0, less than or equal to 3, 0 is less than 3. So I know whatever happens, I know I'm shading this way. I'm just going to draw a bunch of arrows. I'm shading that way. So now this next line, 0, negative 1, I'm down here. Then 3, 0, there's my same point, and 6, 1, I have something going on like this. It's less than or equal, so it's another solid line. My origin's still open. I'll test the origin every time it's open. 0 minus 0 less than or equal to 3, because I plugged my origin in 0, 0, 0 less than 3. Again, another true statement. I'm going to shade up this way now. So now I know that I didn't need that. I'm looking here. If I only had 2 equations, I'd shade this. I have a third. The third says, hey, x is negative 2. If x is negative 2, and it says greater than or equal to, x is negative 2, I'm dealing with x is negative 2 and nothing else. I don't have to use a test point. This time I literally know when they're dealing with a line, a line. When you're dealing with a horizontal or vertical line, just listen to it. It says greater than or equal to. Greater than negative 2 is this way. This is bigger than negative 2. So I shade that little triangle. That is systems of linear inequalities. Again, I think there's a little bit to it, but I think that's easier than section 4.2. I think 4.4 is easier. So don't worry about complicated language. Don't worry about terminology, things like that, stuff that you think might be more complicated. Don't think that it gets more complicated as it goes within the chapter. They just give different ideas. They went from equals to inequalities, unequal. So hopefully that helps. Let me know if you have any questions, and have fun working these out.